Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. In November of 2013, skywatchers around the world eagerly awaited the approach of the Comet ISON. Dubbed the Comet of the Century by several in the media, some astronomers had predicted a stupendous cometary display as ISON approached its perihelion. The comet was also the subject of countless bizarre speculations, from the claim that ISON had somehow turned Mars into a comet, to the idea that ISON was actually the planet Nibiru. However, despite the heightened expectations, ISON ultimately proved to be something of a fizzle. On November 28th, scientists first suspected that ISON had disintegrated as its activity appeared to cease. But as the comet moved away from the Sun, it appeared to flare up before disappearing. Today, astronomers are uncertain as to whether the comet has fully disintegrated, or if inactive fragments may have survived. But several unanswered questions remain about Comet ISON, beginning with astronomers' early overestimation of the size of the comet nucleus. NASA's official timeline of Comet ISON's journey states, NASA's Hubble Space Telescope observed ISON at 386 million miles away from the Sun on April 10th. Preliminary Hubble observations provided surprising results. The nucleus of the comet appeared to be no larger than 3 to 4 miles across. Since the comet was so bright and so active, scientists had assumed the nucleus was larger. However, the estimated size of the nucleus was later downgraded to less than 1 mile. Why do astronomers face such difficulties in estimating the size of a comet nucleus?
The size of the Comet ISON was overestimated at the beginning, and it was downgraded in April to about 3 to 4 miles across. But even then it was expected that as it went around the Sun and being on its first journey, that it would put on a spectacular display and be even more spectacular perhaps after leaving the Sun. That wasn't to be, and the reason for that is that you cannot estimate the size of an object by its electrical effects. ISON shone so brilliantly while it was still located around the orbit of Jupiter, and researchers theorized that the comet brightness meant that it was a rather huge comet. Also, at the time, Hubble observed a gaseous and dusty coma that surrounded the solid body of the nucleus, measured over 3,000 miles in diameter. But in the electrical model, the size of the coma bears no relationship to the size of the object, but to its electrical characteristics, how much charge it carries compared to its surroundings. We have an earlier example where Comet Holmes' coma surprised astronomers by being the largest object in the solar system. When Comet ISON travelled closest to the Sun, it fizzled out, and in fact it was thought for a while that it had disappeared completely. So the question is, how do you take a half-mile wide comet and turn it into nothing? Well, the answer is that the comet display is an electrical phenomenon, so the body itself can remain intact but not put on such a display. I think this is what happened in the case of Comet ISON. In fact, the tail afterwards, when it did reappear, was faint and appeared more like a dusty tail rather than the normal electrical tail. That could have been due mainly to the intense heating of the surface materials. So it's probably one time when the standard model of comets actually was applicable.
While most astronomers predicted a great display from ISON at its perihelion, the predictions of one astronomer who has studied the light signatures of several comets proved to be the most accurate.
Everyone seemed to be predicting that Comet ISON would turn on a magnificent display as it left the Sun and headed towards the outer solar system once again. However, there is one scientist who has a lot of experience with comets, and he was able to point out that it was entirely predictable that Comet ISON would fizzle out. He felt that it would entirely disintegrate. Now, the fact that there is some remnant appears to have appeared after passing the Sun doesn't denigrate his work at all, because he has taken readings of the brightnesses of many, many comets and shown that I think there are about 4 other comets who showed the same characteristics as Comet ISON. That is, the brightness of the comet increases until it gets to a certain distance from the Sun, and then it suddenly decreases and then flattens out and doesn't increase as expected. Now, he predicted back in July of this year that Comet ISON would disappear, and he was almost right, it seems, with this particular comet. From the electrical point of view, looking at comets as an electrical phenomenon, it seems that we have to be careful not to apply the electrical model to the exclusion of the standard model. And I say this because the electrical model of a comet provides the star-like brightness of the nucleus in the form of cathode discharge. It provides explanations for its filamentary tails, which are not explained very well by standard theory. But what happens if the discharge goes out? If for some reason the comet reaches accommodation with its environment and the discharge quenches? And this is quite sudden. And this is the kind of thing that the astronomer Ignacio Ferrin points out in his paper, that the light curve of these comets that fizzle out suddenly drops. It's a sudden event, and it's not explained by any standard theory. However, from the electrical model, of course, an electrical discharge can stop suddenly. It stops and starts suddenly. Ignacio Ferrin points out that the very sharp discontinuity in brightness of the comet as it approaches the orbit of the Earth and closer to the Sun implies that it's not an outburst, a cometary outburst. And he says there is some fundamental physical process that goes on here that we do not understand. And I would suggest that that physical process is the quenching of prior electric discharges. So it appears that in the case of Comet ISON, it was already beginning to sputter. The discharge was beginning to sputter before it reached its orbit close to the Sun. And when it went around the Sun, it brightened up, of course. But after passing the Sun, it appears that all we saw was a dusty tail and no nucleus. And this is what I would expect if the discharge was quenched and the dust and so on that was being produced was rather like that of an asteroid. Recent asteroids have shown a dusty tail as they passed around the Sun. In that case, just the sheer heating of any volatile material on the surface, or the extreme gravitational effects as the comet swings around the Sun, all of these things can tend to tear it apart or to pull material off the surface and distribute it. Referring to Professor Ferrin's statement that the complexity of the change in brightness of Comet ISON and others like it is unexplained, should also be looked at from the electrical comet model from the point of view of the change in nature of the surface of the comet as it gets very close to the Sun. As it's out beyond Earth's orbit, the comet acts like what's known as a cold cathode. In other words, the material of the cathode itself is cool. In fact, it's very cold in the case of a comet. However, when it reaches the vicinity of the Sun and swings close by the Sun, that cold cathode becomes a hot cathode, and the discharge characteristics will change as a result. And this is the kind of thing that's noted by Professor Ferrin in his charts of the brightness changes in comets. So this is something else that has to be considered. So the comet behavior is quite complex, but at present the astronomical view of comets as being dirty snowballs just does not fit. An entirely new approach is required.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.